Okay, we talk about leaves. Leaves are green photosynthetic organs uh, of a plant arising from the nodes. So we have discussed this before. Leaves are usually flattened, either bifacial or dorsiventral, which is where you have two face. Okay, bifacial, two face, or we can they can call it as a dorsiventral, which has a adaxial with an adaxial part. Okay, with an adaxial part, which is the side upper surface, the upper surface that facing the stem. So if let's say you have a where so you have a stem here, and then you have leaf, the one that facing the surface that facing the 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 plant, the one that facing the plant, the stem, we call it a adaxial D with D dodol, donkey, adaxial. Okay, so and then the lower part, the other part that opposite to the stem, we call as a abaxial. Okay, it is facing away from the axis. So or maybe it's also that's is if it is a bifacial. So some of the plant also have a unifacial or isobilateral with some adaxial and abaxial surfaces. So a leaf is in general differentiated into a leaf blade, what calls a lamina, and a petiole. So a leaf with a distinct petiole is termed petiolate, whereas one lacking a petiole is sessile. We'll talk about this later. So leaves have been used a lot for taxonomical characteristics simply because the morphological characteristics of the leaves are consistent throughout the lifetime of the plant. I can say the most consistent features of the plant compared to others is the leaves. So it's easy to make a characterization or classification, although it cannot explain everything. Here are some of the characters in leaf that use for identification and characterization. Yeah, so these are the groups of terminologies, if I can say. So I can't cover everything in this lecture, of course, but I try my best to explain the most common features that I feel enough for you to grasp the idea. Again, you can always refer to the textbook for details explanation. Before we go further, I just want to introduce some general terms here, and these are terms that can be used for any organ, not only for it's not specific for leaves, then it can also used for stems or any other kinds of things. They are oftentimes shape terms, and there's a whole heck of a lot of them, but the good news is that we don't have to learn a lot of them. So uh, just just I just want to give you some idea about it. So most of these kinds of terms that you are going to look up if you ever encounter them in keys or in descriptions of plants and so on. So they tend to be a little more technical terms. There are sometimes a few of them that are more likely to be occurred. So like here is a what we call as a capitate. It's oftentimes there's a capitated glands, and we may see some of those, especially in the mint family, and they come out of glands that are capitate. This kind of spherical shape here. Terete is kind of a solid cylinder. It's kind of a solid cylinder and means circular in cross section like this, but extended like a cylinder. All these other ones are not as common, and you may see them, but if you do look them, if you do, you look them up in the key or in the glossary. Okay. Pretty much the same for the shape terms. If I was to say the most important terms here, sometimes we see linear leaves. We see ovate leaves. Where is the ovate leaves? So we see the ovate leaves here. Okay. We see elliptic leaves. Okay. Elliptic leaves. Okay. Those are the main types of or for the leaves. The other thing is that this word ob, Okay, this is OB. Okay, uh, the prefix OB means inverted or upside down. So, which means is if we have an ovate leaf, we can pretty much know what shape an ovate leaf. So, ovate leaf. So, we have ovate leaf, we have an ovate leaf. So, these are the shape of ovate, and this is a ovate, the opposite of ovate. So means upside down. First of all, okay, remember that we're talking about the leaf. Okay, so here is the leaf, and in the axil of that leaf you have the bud. So I just want to recall here in this, if this is the leaf, and then you have the bud here at the axil, at the armpit. Okay, so that's the most important thing to get here. Looks like, let's look at these two basic leaf types. uh, so we have here on the left is a simple leaf. This is a simple leaf. You can see that there's a single blade. So there's a single blade, so called a blade here is a single blade to that leaf, and it's not divided up. So on the other side we have a kind of compound leaf. So these are all compound leaves. Okay, and in these cases we have a blade, but it's divided up into parts, and those parts are called the leaflets. So we have a leaflet. Okay, but how do we know that they are leaflets and not full leaves? Again, well, we look at in the axil of those little leaf-like things, and we see that there is no bud. If there is no bud here, which means that, oh, these are a part of the leaves, so of the or the leaflets. We do look, and then, and if you look, and if we go down and look at the base, look down here, and then you can find there is a bud over here. So that tells us what we have. The whole thing here is a leaf. This whole thing here is a leaf, and the division here is the leaflet, or leaf-like. So even though it doesn't really look like a leaf, this type of leaf is called a pinnate leaf, compound leaf. So this is a pinnate leaf compound leaf. Pinnate means feather, okay, or pinna means feather. So they are pinnately, which means feather-like leaves, because they are organized like feathers. Now there are a bunch of different types of pinnately compound leaves, and we've got some of them over here. We are not going to worry about these terms for now. So these are the kinds of things that if you encounter them in a key, you need to consult the glossary for that key and find out what those terms mean. The big division we need to understand is the difference between the compound. The compound is this, the all 1, 2, 3, 4, the compound leaves, and also the simple leaves. Okay. There's other type of leaves. There are still compound leaves, if I can say, but these are different types of compound leaves. So you're going to look at on this slide what we call as palmate. Okay, palmately compound leaves. So they are palmately compound because they are look like a hand. They look like a hand. So there's all kinds of different palmate leaf, compound leaves, just like there's different kinds of pinnately compound leaves. Again, we are not going to read so much about the differences of the different types of compound leaves, but we are just going to all call this, they are all palmately compound leaves. So we have a palmate, ternate, pinnate, ternate, biternally compound, palmately compound, so on and so forth. Okay, you can see that sometimes they are really highly divided up into really tiny leaflets. Okay, and there are all kinds. Then there's all kind of terminology for that. Okay, you can look at and then try to understand. But basic idea, you need to understand between what's the difference between a simple pinnate and palmate compound leaves. The attachment of the leaves. So how the leaf attached to the stem. This can be really various. Okay, I mean, there's all this stuff is extremely variable in all of these plants. So of course, all the terminologies are very it's a lot of variation. Remember, there's more than 250,000 angiosperms, and so when you've got that many plants, of course, you've got a lot of variation to deal with. So we are going to be dealing with the mainly with the types of leaf attachment that occur on the left on this diagram. I'll try to concentrate on this first. These are the ones do occur. They are really cool when you see them, but we are not going to worry about them right now. Okay. Again, these are kinds of things when you encounter these terms. Okay, the current and flexible profoliate connect profoliate. Okay, when you encounter this and you've got a weird plant that has them, take a minute and learn the terminology for it. So I think that the times that are the two types that are most common for us are this type uh, of leaf, petiolate, that we've looked at already, where there's a little stalk at the base of the leaf. And this one over here is sheeting, uh, where there's a stalk and a sheath at the node. So in the first case over here, we have the blade. So we have the blade here. We already looked at that, but now we have a petiole. And petiole means a little stalk. And notice that down in there is a bud there again. There's a bud there. So the petiolate leaf just means there is a little stalk on it. Now, on this kind of leaf sheeting, we have a blade again. There is a blade. There is sometimes a petiole, where it's not always, but there is sometimes a petiole. And now the new thing is that there is a sheath. So there is a sheath that occurs on those leaves. This is a very typical for the grasses and other families that are like the grasses, where we have sheathing leaf like this. Okay, a third type that is not so common is the sessile is the sessile leaf, and in this case there is just no petiole. Okay, so these are the main types of leaves and the leaf attachments. The venation of leaves. So now this diagram goes into more detail than we need. There are basically four types of leaves, if I can say, shown here. The first type, which is called uninervous, means only one vein. Okay, now that's a really great description of these leaves, but it's not the most common term here. This type of leaves usually called in many textbook called as a microphylls. Okay, called microphylls, and they are characteristics that they only have one vein. So almost every textbook I've ever seen has called the microphylls, so we are going to use that term instead of uninervous. But of course, uninervous is more descriptive, or to say as one nerve, one vein. The second type of leaf I'm going to look at is down here. Is a leaf of plant like a ginkgo. I have experienced myself to look at the live ginkgo plant when I studied in the US. That has what is called a dichotomous venation. So dichotomous means to cut into that leaves, so, or the veins of a dichotomous leaf come up and they branch, and they always branch into twos, two, right? And if we were to follow the branches up further, okay, follow the branches up further, leaves are really kind of net vein and parallel veins also. So you can look at the branches of the vein, so they always cut into two. So that's what was what we call as a dichotomous vein. So this number three is the category that is what we call as net veined. And if we were to look closely at those leaves down here, okay, we see that there's these little nets, that really tiny division in here that form this what we call the very smaller division of the leaves. Okay, Now the major veins can be pinnate like this one. This is this, or they can be, or also they can be a palmate. Okay, you can have pinnate or palmate. So and apa, and then the sub a special term for all of these those kinds of things. But when we look down or at the details, they are net veined. Okay. The other main type is parallel vein. This one a parallel vein. Uh, and we see that here most clearly in this type of light leaf, typical for grass leaf. So the vein at this very fine level are parallel. Okay, parallel straight like this. There are sometimes little cross veins in the parallel leaves, but they are not forming a net like in the vein, uh, uh, the, the 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 netted vein like in the this one. Okay. So in terms of leaf base, okay, we have when you look at the leaf, there's the base of the leaves also have many characters, shows many variation, and this has a lot of terminologies, but there's a lot of integration between this type of bases. So perhaps the most common time we might say is obtuse here, which is an angle that's little greater than 90 degrees. But you might find on the same plant some leaves that are up to 90 degrees, some leaves that are cuneate. So in same plant, but the base, the leaves of the plants have variation in terms of the angle. So of course, n- not how to say, probably not getting to this narrow on the same plant, but there can be a lot of variability in terms of the of this obtuse. So obtuse is probably the most common of these types of terms. This term here, the peltate. Okay, peltate means umbrella shape. So just with the stalk going right in the center, you can explore yourself, look at the plants around you, look at the leaves around you, and try to look at the base and then can you tell me, how can you tell what shapes are there? So you can look at, and then you can try to differentiate. So this is a very specific, the shape is very sometimes very specific for certain species, also even certain families. And yet there's a lot of types of leaf margin also. Okay, you look at the margin of the leaves, the important ones that probably the entire. So this one is the entire and serrate. Okay, or some versions of some version of serrate. All the others like cerulate here. Okay, it's like a serrate, except it's got smaller teeth, a little bit sharper. Okay, not sharper, it's a little bit serrate is quite wider, and the cerulate is quite close with each other. Again, you can look this up if you encounter them. Please refer to the textbook for other examples of plants with specific leaf margins. So the shape of the apex, we talk about the base, we talk about the margin. Now we look at the top, the apex. Again, a lot of different types of shapes. Here I would say the most common one is the acute. Okay, the acute. Leaf incision. The leaf incision is a leaf with a single blade, what we call as a simple leaf, or the compound leaf has one with two or more distinct blade. Now this is really a diagram that shows an attempt to make very precise terms for the kind of incision or division that you could have in leaves. I'm not going to explain in details, just if you encounter them. If you encounter this kind of terms, you have to look up what it looks like. Now, arrangement of the leaves. So there's a number of different kinds of arrangements. There's a spiral arrangement of leaves, and that's very common. And there is an arrangement that is called a distichous. Distichous. This is also alternate arrangement of the plants, which means that the plants in the stem they go alternately. And then this distichous is that there's one. Okay, sorry. There is one leaf blade going out, and then after and this side, and after that one leaf on the other side. and one leaf on this side, on one leaf on the other side, one leaf on this side, one leaf on the other side, and it's continuing up to the stem that they are in two rows up the stem like that. So kind of like uh, uh, alternate in a parallel way. Okay. Another type of leaf arrangement is called opposite. You have the alternate. I also call it opposite here, but the main thing what we want to consider with the opposite is that at the same note we have two leaves. So this what we call as the opposite. This means that if let's say the alternate you have let's say you have one plant, so you have this and then they go up alternate like this. But the opposite is just you have the same leaves at the same note. Okay, so that's the one means as a opposite. So the main thing we consider with the opposite is that at the same note we have two leaves. So we see that in all different varieties here, two leaves at the same note that we consider the opposite. The whole is the case here where we have three or more leaves at the same note. Okay, if there is a two plant, we call it the opposite. If we have three and more, we call it as a whole. It's the case where we have three or more leaves at the same note. Lots of different kinds of that also, different type of plants that have this kind of features. The two types, oops, sorry, the two types of overlapping of bracts now or bud scales and buds are imbricate and valvate. So this is imbricate and valvate. I just keep here and there. Uh, where and you'll encounter this in the keys often. Imbricate means overlapping, and valvate means like a valve, let's say like a clamshell, so like clamshell, right? uh Fasciculate. So fasciculate is just having the leaves in fascicle like, so mainly in the Pinaceae, in the pine. The acutan and second here is a is we probably won't deal with plant with acutan and second leaves so much or so frequent. So these are how the leaves are arranged. Okay, some of it. Okay, same thing with this structure that talk about either the surface of a structure or about the shape of it, like this canaliculate. uh, it means it has a canal on it. Okay, it has canal in it. Punctate. Okay, means it's a punch with a little tiny hole. Sometimes the holes don't go all the way through the punctate leaves, but there are little transparent places. We are not going to read about it a lot. Same thing with these different kinds of epidermal structures. Okay, so these are epidermal structures. These are leaf surface. There's outgrowths. Okay, in the leaf surface, there's kind of prickly outgrowths of the leaf. So there's a prickly. There's a so this is the leaf surface. This kind of this of all kind of all this the leaf surface, and then they have different types of outgrowth. Okay, these are all the different type of characteristics. So I'm not going to. There's a prickly, scurfy, papillate, and muricate. So these are different types of that. So it's sometimes in terms of the surface, it's very hard for you to look at with your naked eyes. You need to have uh, uh, s- uh, microscope to look at, or probably SEM to look at these features. So some leaf surface can be glaucous, which has a waxy coating, uh, and then also you can have a viscid, which is a sticky secretion on the leaf. The surface of leaves, stems, and other organs may present a variety of surface indumentation, whose characters are highly diagnostic in several taxa. So the surface may be covered by trichomes like the hairs, glands, scales, etc., and then it can arrange variously. Okay, so if you thought it was complex up till this point, you should see the terminology for pollen or the male reproductive organs of you can see the at the planta male reproductive parts of the plant. Just incredible terminology associated with pollen structure. If you are interested in the palynology, I only know one retired professor, expert in palynology. I can't see any more here in Malaysia right now. Who study pollen, or if you like to study about the pollen, you need to really understand the surface structure, and then which is more complicated than this structure for the leaves. Oh, before I forget, this glabrous. Okay, glabrous, which means smooth or without trichomes. So trichomes is another word for hairs. Okay. Okay, going back to trichomes, I think I want to touch a little bit on trichomes as we already talked before. Trichomes, as I said, are hairs. Lots of different types of hairs, as you can see here. Okay, you can refer to the books for more examples of species with specific trichomes. Remember the peltate, talk about the umbrella shape. Again, different types of these hair occur in very specific families, like here the Glochidiate. This is a hair that is in the Cactaceae. It occurs in a specific kind of species in the cactus family. So, okay, that's all about the basic or common terminology of the leaves.